this session where we will be learning about operating systems and networking topologies. In this session, we are going to learn more about operating systems, definition, functions, types of operating systems, and what are the trending operating systems. And we will also be discussing a bit about networking topologies. The definition of operating systems goes like this. An operating system is the software that manages the operation of the CPU, controls the input and output, storage resources and activities of the computer system. It also provides various other support services as the computer executes the application programs. It's the most fundamental software on a computer as it enables all other applications to function. Now, by this definition, we understand an operating system is an interface between the user and the computer. Now, when we say interface, it simply means it is a medium or a software package which has a set of instructions or codes written which is required by the computer. Now, that is the reason it is called as operating system. It enables the operations on the computer. Now, all the activities on the computer system is controlled by the operating system. There is no single function which goes unnoticed without the knowledge of OS. Without the operating system, a computer is like a blank machine. So, an operating system needs to be installed in the first place as a fundamental software, and then we will be able to install lot of other applications or software packages. Through this diagram, we are able to understand the operating system consists of certain layers. Like if you look at the system software particularly, where the operating system is the part, we see like there are a set of utilities and programs which are basically enabling various functions which are part of the operating system activities. Now, once the operating system is installed, we can also have application softwares installed on that. There are various applications like computer games, spreadsheets, word processors, database, internet browsers, or any other software what you want to install can be installed once you have an operating system. Now, whenever we buy a computer system, be it a desktop, a laptop, even a mobile, it consists of an operating system. One of the most commonly found operating system is Windows. Maybe if it is a business organization, there is other type of software package or an operating system which has been installed. Now, let us try to understand different functions of operating systems. An operating system is the core, we said. So, it performs certain functions like acts as a user interface. So, when we say user interface, basically it could be menu driven, command driven or graphical user interface driven. So, when we say it acts as a user interface, it could be like a menu driven where you have a list of commands from which you choose, or command driven. So, you give the command for interpretations to execute the commands, or it could also be graphical user interface where you get a screen, icons and graphic utilities on which you can click and perform the activities. Now, this is where like it acts as a user interface. The second function of the operating system is resource management. Now, it manages and controls all the resources. File management, like organizes and controls all the data storage, retrieval of data storage and deletion or updation of data storage. Task management, like we say multitask or multi-processing abilities. So, the operating system is the fundamental which enables that multitasking ability. And above all, it also performs the security and access control activities. Now, authentication or permissions are granted based on the operating system settings. Now, having understood different types of functions an operating system is performing, let us explore more on different types of operating systems. In general, we have been hearing more about Windows, Linux or Solaris or maybe some other operating systems. When people are using MacBook, they might say like, I have an iOS. So what are these different types of operating systems which are used by different segment or group of people or organizations? To start with a little bit of history, disk operating system, which was designed around 90s, was one of the most popular operating system during that time, and it was single processing and single user oriented. Now it had lots of limitations, but it was greatly useful. It had internal and external commands, and people enjoyed using a disk operating system. And it was a command driven interface. Now over a period of time, Microsoft designed MS-DOS, which had a window integration and simplified the user interface. Now the window, which started as an interactive page, became one of the world's most popular software called as Windows, and it is most user-friendly operating system according to many people. Now as we move ahead, MS-DOS Windows was multi-user, multitasking, multi-processing, and above all, it was a graphical user interface. Now Windows over a period of time was released with upgraded versions like Windows XP, Windows Vista, Windows 7, Windows 8, or maybe you come across something like Windows 2003, or the latest what we have is Windows 11. To be specific, there are different versions of Windows operating systems which are released for professional purpose, home purpose or enterprise purpose. Now we also have Linux operating system which was designed much prior than Windows or DOS. Linux takes its roots from Unix, and Linus Torvalds designed this around 1990s, and it is one of the most used graphical user interface because it is having the strength in terms of networking, security and distributions. Now when we look at the different types of operating system, by now we have understood we call like single user, just now as we discussed, like DOS, multi-user, we have Windows, Linux, and there are also other type of operating systems like real-time operating systems or networking operating systems, and with the smartphones today we also have mobile operating systems. Now it is said that the number of mobiles is exceeding than the human population. Now with that we need to understand there needs to be a simple software package which will enable all the functionalities on this mobile. So we also have mobile operating systems. The increasing demand for mobile phones like Android and iOS, the two dominant mobile operating systems in the world, with Android accounting for around 70% of the market share and iOS at around 29%, gives scope for lots and lots of designing and improvement of features with respect to the mobile operating systems. And more than 1 billion iPhones and over 3 billion Android devices are currently active. Now all these statistics are recent, and where is it going to end in the coming years? We just have to wait and see, because there is new mobile designed every now and then, and what type of new feature is required or new type of operating system is designed, we just have to wait and see. The reason is these operating systems are slightly different from the operating systems which were there on the computer, because mobiles have multi-utilities and different features which are required for different transactions. Now some of the popular operating systems are Windows operating system, like presently we have Windows 11, Unix, Linux, and we have Mac OS from Apple for MacBooks, and we have iOS for iPhones, and we have Android. So normal smartphones have Android operating systems. Now with all these operating systems, which are quite widely used in industrial scenarios or day-to-day life on multiple devices, we need to understand some of the trending features with respect to the operating systems. Now these technologies, be it Internet of Things, cloud and edge computing, quantum computing, artificial intelligence, immersive technologies, require a different type of operating system. Now let us spend a little time on understanding what these concepts are. Internet of Things. Now Internet of Things is a network of physical objects connected to the internet. They can communicate with each other and with other devices. IoT devices are embedded with sensors, software and other technologies that allow them to collect and share data. Now it is said that the number of devices connected to IoT are more comparatively 5 years ago. We all are dependent on smart sensing devices, be it a wristwatch on the hands, which tell us about the day-to-day trackings, could be anything about the health or calls, or it could be a home appliance which is talking to the device like your wristwatch or a phone, or it could be your car which is moving on the road but still trying to connect multiple utilities to enable communication. Now all these exchange of communication between these devices is possible with the help of Internet of Things. Now in the diagram we can see Internet of Things is connecting not only the factories or business centers like airports, shops, or maybe like cities, IoT enabled cities, or airplanes, trains, ships in terms of logistics. It is even useful for residences like IoT enabled homes and buildings. Now with IoT, there is communication facilitated between all these physical objects and enables simplification of decision making when the right information is available or when the device indicates what to do next or some automated process which enables certain actions. Moving forward, we see a graph which indicates that how Internet of Technology is catching and giving scope for multiple business utilities. And majority of these industries today are dependent on certain technologies like IoT, and we can also understand like the global spending on enterprise IoT technologies is increasing so rapidly. The what type of operating system might be required by IoT? There is TinyOS, an open source component based operating system which is for low power wireless devices. It is event driven and popular with developers because of memory optimization abilities. We also have RIDE, and this is an operating system which meets the requirement of IoT with a low memory usage, high energy, very efficient with real-time capabilities. We also have Linux, an open source operating system that's the backbone of many IoT systems. So what could be the type of operating system required by cloud and edge computing? Before that, let us try to understand what is cloud and edge computing. Cloud computing processes data in a centralized location, often a data center, while edge computing processes data closer to the source, such as maybe where that activity is happening or the device is located near to the local edge server. Now, cloud computing is good for data storage and scalability, while edge computing is good for real-time processing and low latency. Now, organizations can combine both of this to achieve higher efficiency or to optimize performance. Now, for Cloud computing and edge computing, most popularly used operating systems are Linux or AWS, Microsoft Azure IoT Edge. Now let us look into the difference between edge computing and cloud computing. Now if you look at this table, we understand that edge computing, the bandwidth requirement is low and the data is processed near the source, as we said few minutes ago. While cloud computing has higher bandwidth and the data must be transmitted over the network to a central location for processing. Not only that, when it comes to certain utilities like AR and VR, edge computing would be better to give the nearest experience, while if it is something like applications that do not have strict latency requirements such as like web applications, email and file storage, one can use cloud computing. Now in case of cloud computing, data security is quite challenging. Now we need to keep in mind which of these is more suitable, or maybe combining both of this at certain points would be more beneficial, and use the respective computing systems. We have quantum computing next. Now today, quantum computing is a multidisciplinary field comprising aspects of computer science, physics and mathematics that utilizes quantum mechanics to solve complex problems faster than on classical computers. The period of time for which a process is allowed to run in a preemptive multitasking system is generally called the time slice or quantum. Now the quantum computers work on qubits, like it is designed especially for the time sharing system. Now this is useful in complex scientific calculations in various sectors like healthcare, energy, environmental systems and smart materials. Now Windows and Linux are some of the most popularly used operating systems when it comes to quantum computing. It doesn't end there. The government of India has spent a whopping amount of 740 million for 4 thematic hubs, so what is called as T hubs, at a major educational and research institute for applied research in quantum computing, communications and sensing capabilities. Now, the Department of Science and Technology has 3 similar missions for interdisciplinary cyber physical systems, supercomputing and climate. Now, this itself tells the significance of why Government of India is spending so much through its National Quantum Mission. Now, that was based on a mentioning in the research paper. Now, if we look at the government or governance schemes, now National Quantum Mission India is an initiative by Department of Science and Technology, Government of India, to foster quantum technologies related to scientific and industrial research and development, to support various e-governance projects like Digital India, Make India, Skill India and SDGs, Sustainable Development Goals. Now, it's not only with the governance. Quantum computing is spread across in large weather forecasting, scientific calculations and large-scale operations. Next up in the slide, we see how Volkswagen is using a combination of different utilities what we were discussing till now. If you look at this particular representation, we see like Volkswagen Group is Europe's largest car maker, producing 11 million cars annually. Now, in the automotive manufacturing and logistic processes, the group has built industrial cloud on Amazon Web Services, AWS, which uses IoT and connects data from machines, plants and systems across their 120 factory sites. The Volkswagen Industrial Cloud aims to yield a 30% increase in productivity, 30% decrease in factory cost and save €1 billion in supply chain costs. The group is also using AWS to expand beyond manufacturing into ride-sharing services, connected vehicles and immersive virtual car shopping experiences to shape the future of mobility. Now, From this, we understand the technologies what we were discussing till now have been used in industry for productivity, reducing cost or achieving efficiency. Artificial intelligence is also something which has been most discussed these days. So, artificial intelligence allows machines to learn from data, recognizes patterns and make predictions. AI can also perform tasks such as autonomous decision making, recognizing speech and solving problems. Now, the application of AI has become quite common in healthcare, finance, retail and manufacturing. Generative AI, OpenAI is some of the trending. So, generative AI and OpenAI has been some of the commonly used concepts these days. Moving forward, we have immersive technologies. Immersive technologies create distinct experiences by merging the physical world with the digital or simulated reality. Augmented reality, AR, and virtual reality, VR, are two major types of immersive technologies. Now, these technologies share the same qualities. Now, by incorporating such VR, AR, interactive displays, touchscreen technology, these spaces create engaging multisensory environments that encourage exploration, curiosity and learning. Now today immersive technologies has been one of the trending things when it comes to multimedia, gaming, entertainment and anything which is related to the cognitive associations. Not only that, AR and VR are integrated even on smartphones, and with addition of a smaller application or a virtual reality headset or a device, the user can gain a similar immersive experience. Technology has enabled all these devices in a very affordable way. Now, having understood all these operating system and training operating systems and functions of operating systems, we will learn a little bit about networking topologies. A topology is a kind of arrangement. Networking topology is the arrangement of computers and other devices to share resources and informations. Usually, nodes and links are used with a server and client architecture or peer nodes where the data can be moved, stored or transmitted. Now, there are two types of topologies. One is the physical topology or the logical network topology. Now, physical topology is a structure where it is visible, while in the logical topology, it might not resemble the physical structure as represented, but there is a sequential or arrangement done as per the topological order. Now, let us look into various networking topologies. Every topology has its own advantage and limitation. We have different types of topologies like point-to-point topology, bus topology, ring topology, star topology, tree topology, mesh topology and hybrid topology. Now, each of these topologies are required, or one can make a combination of any of these topologies to achieve their purpose of network arrangements. To start with, point-to-point topology is the simplest communication between two nodes. One node acts as a sender and the other one acts as a receiver. So, there is point-to-point high bandwidth of transmission of data from one point to other point. Now, bus topology is one of the most popularly used structure. It's cost effective and easy to set up, but it's vulnerable to cable failures and signal quality, and if there is any disconnection, it affects the whole process. Now, bus topologies are less common in modern networks and have been largely replaced by star topologies. We have ring topology where the computers are arranged in a sequential order in a circular manner. Now, there is a concept of tokenization where the data travels in one direction around the ring, and whichever device meets the tokenization, data is transmitted to that node. Ring topology is often used for simple networks such as in small offices with a few nodes. We have star topology where we have computer in the middle and all other devices connected to it. Now in star topology, the benefit is the network structure of all the devices are connected to the central hub, commonly used in modern computer networks because it allows reliable and efficient connections between multiple machines. One connection lost would not create any problem to other computers. Now that's the advantage of a star topology. Next we have tree or hierarchical network topology. A hierarchical or a tree topology resembles a central or a main node like a trunk, typically like a branching out or sublevels are created where each node is connected to the central node through a single path. The nodes are like branches coming off the trunk, and that's the reason it's called as the tree topology. Tree topologies are often used to create large networks. We also have mesh topology where every system or node is connected to other system, and this is quite a decentralized networking concept. Now, when you look at the mesh topology, the devices are connected in a decentralized manner without a central hub or switch. Instead, each device is connected directly to multiple other devices, forming a mesh-like structure. Multiple paths for data to travel, enhancing redundancy and fault tolerance is one of the features of mesh topology. We have hybrid topology, which is a combination of any of the earlier topologies what we discussed. It could have a point-to-point topology, or it can have a bus, ring or tree topology. Whatever combination is required is combined to form a hybrid topology. So this is quite commonly used when we want multiple network topologies to create a new network that doesn't fit into any one standard topology. The goal of hybrid topology is to use the strengths of each topology while minimizing its weaknesses. Now each of these topologies what we discussed has its own advantages and limitations. One needs to select the topologies which is beneficial for their requirements. Now let us take a look at some of the interesting facts. The PC market leaders. In 2023, Lenovo was the leader in the global PC market with a share of just 25%, while HP was the second largest vendor with 22% of the market. Now there are around 10,000 mainframe computers in the world. Mainframes are often used by organizations that handle large number of daily operations, maybe like banks or share markets. Now we have been seeing the increasing use of iOS and Android OSs. Since we were discussing about operating systems, we also need hardwares on which these operating systems reside, so it's all interlinked. Let us take a quick look at the references used in this section. Now let's take a look at the session highlights. In this session we discussed operating systems, definition, functions, types of operating systems, and we also discussed networking topologies. In the next session, we are going to continue with the types of networks. Thank you.